In number 28, we're going to solve a radical expression, and in order to do so, we have to get the radical on one side and numbers on the other so that we can square both sides. So let's add 4 to both sides, leaving us with y plus 7 equals 8. And now we can square both sides, and we have y plus 7 equals 64. And then we can subtract 7 from both sides. 64 minus 7 is 7. And we can check that out by putting it into our original equation. 57 plus 7 minus 4 should equal 4. Square root of 64 minus 4 should equal 4. And 8 minus 4 does equal 4, so it checks out. Now we are simply to simplify this expression, and so we have to distribute that negative sign throughout what is in the second parentheses, which changes the sign of everything inside. Now we combine like terms. Our real components are 4 minus 5. And our imaginary components are minus 2i plus 3i. So our final result is negative 1 plus I. Now we're going to multiply. I want to remind you of the formula a minus b, all of that squared equals a squared minus 2ab plus b squared. You can also rewrite this in this fashion and FOIL it, but I'm going to use the formula. So we have the first term squared, 3 squared is 9. The last term squared, 2i squared. And the middle term, since there's a minus here, we're going to have a minus 2 times 3 times 2i. A plus always goes there. So we have 9 minus 12i plus 4i squared. I would write it like that to make sure you don't mess up the negative sign, because I squared is equal to negative 1. So we have 9 minus 12i minus 4, and that gives us 5 minus 12i. On page 8, number 31, we are told to solve and give the exact solutions and the approximate solutions to 3 decimal places when appropriate. We give approximate solutions because the square root of something that is not a perfect square is going to be irrational, and that means it is a decimal that does not terminate. So we are told to give our approximate solutions to 3 decimal places. To give the exact solutions, we do not actually take the square root, we leave the radical sign in place. But first of all, to solve these, we need to get the x squared by itself. So let's add 3 to both sides and divide by 2. And now we know that x equals plus or minus the square root of 3 over 2. So that's going to be plus or minus the square root of 3 over the square root of 2. But we can't have a radical in the denominator, so we multiply, since it's a square root. We multiply by square root of 2 over square root of 2, and so in the numerator we have the square root of 3 times the square root of 2, which is the square root of 6. And in the denominator we have the square root of 2 times the square root of 2, which is the square root of 2 squared, which is 2. Okay, so x is either plus square root of 6 over 2 or minus square root of 6 over 2, and no, you cannot divide the 6 by the 2 because they are unlike terms. Okay, let's look at, that is the exact answer, but they want us to find an approximate answer. So what you're going to do is take the square root of 6 on your calculator, and you get 2.4494, blah, 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 blah. we need it to 3 decimal places. So I'm going to write it out. X is approximately equal to 2.4494. I'm going to write it out to 4 decimal places so we know how to round. We know how to rhyme, don't we? Okay, so to the right of the line I just drew is a 4. That's less than 5, so that means we don't round. And so to 3 decimal places, X is approximately equal to 2.449 and exactly equal to square root of 6 over 2. Now let's look at the second on B. We already have something squared equals 7, so we can take the square root of both sides. Let me make this clearer. And the square root of a square is itself equals square root of 7. X equals negative 11 plus or minus, I've got my plus or minus here, square root of 7. So that's the exact answer. And now the approximate answer, we have to find the square root of 7 to 3 decimal places, and the square root of 7 is 2.6457, so on. So we're going to say the square root of 7, we're going to write it out to 4 decimal places. Draw our line, look to the right, since it's greater than or equal to 5, that makes this round up, and then we can discard that, so we have 2.646 for our square root of 7, but X equals negative 11 plus square root of, well, let me write it 2.646. And I forgot my plus or minus here. And also negative 11 minus 2.646. So we have X equals negative 8.354, or X equals negative 13.646. And that is not really equal, it's approximately equal. And again, don't forget your plus or minus. In number 32, we're going to complete the square to solve. So we have x squared plus 4x equals 2 to start with, and what we are going to do is add something to both sides of the equation so that we have a perfect square trinomial. Now, look over to the right where you see a general form of this. X squared plus bx equals c, where b and c are certain numbers, like in this case, b is 4 and c is 2. Your first thing to do is take that number, whatever b is, and divide it by 2. You're going to need that number. Next, take your b over 2 and square it. You're going to need that number. The b over 2, all of that squared, is what you're going to add to both sides of the equation to create a perfect square trinomial. So you have your x squared plus bx that you start with, add your b over 2 squared term, and then that equals c plus, and you have to add it to this side too. After you do that, then you can rewrite it as a factored from the perfect square trinomial, x plus, and then that's where you use this b over 2 number, and then square that whole thing, and that gives you c, a number that's going to be c plus b over 2 squared. Now, if you don't like b's and c's to talk about numbers, let's do a real world version of this. So we need to add something to both sides of this to give us a perfect square trinomial. We need that b over 2 is our middle coefficient over 2, which is 2. And we need to know that b over 2 squared is going to be 2 squared, and it's going to be 4. And this 4 4 is the number we add to both sides. You do not have to trouble yourself factoring the first one if you know the formula that a perfect square trinomial is going to be the roots added together or subtracted if you have a subtraction here. That shouldn't be r. So the root of 4 is 2. So b over 2, right? 2 is the root of this 4. b over 2 goes there, and you square it, and on the right you get 6. So that is what you do to create a perfect square trinomial that you can factor. So x squared plus 4x plus 4 becomes x plus 2 squared. Okay, now you know how to solve this. You have a square on the left and a number on the right. So all you have to do is take the square root of both sides and put a plus or minus on the right. So x plus 2 equals plus or minus the square root of 6. Subtract 2 from both sides, and you get x equals negative 2 plus or minus the square root of 6, which is a number. And so you could actually find an approximate solution, but since they don't ask us to do that, you don't have to plug that into your calculator. Number 33, we solve r squared plus 3r equals 8. We can do it using completing the square or the quadratic formula. First, we'll complete the square. We need b over 2, which is 3 halves, and b over 2 squared is 9 fourths. So we're going to add 9 fourths to both sides, and we get, so on the left you get r plus 3 halves squared, because you just use that formula for a perfect square trinomial, equals 8, which, since we're going to add it to a fraction, we're going to put it as a fraction, 8 over 1, and multiply it by 4 over 4 to get the same denominator as this 9 fourths. So it's going to be 32 over 4 plus 9 fourths equals 41 over 4. So now we have r plus 3 halves, all of that squared equals 41 over 4. We take the square root of both sides, plus or minus the 41 over 4, and we get r plus 3 halves equals the square root of 41 over 2, and of course there's a plus or minus there. So we subtract 3 halves from both sides. We get r equals negative 3 halves plus or minus the square root of 41 over 2. Okay. So that's the complete the square. Now let's do the quadratic formula, where a equals the coefficient of the squared term, b equals the coefficient of the middle term, and c equals the number. And notice you have to bring that 8 over. You have to rewrite the equation so it is equal to 0. So r equals negative 3 plus or minus the square root of 3 squared minus 4 times a times c over 2a, which is 2. Get my eraser working. So that's going to be negative 3 plus or minus the square root of 4 times 8 is 32. The negatives cancel. 9 plus 32 is 41 over 2. And that is the same thing. We can rewrite that to be perfectly identical. But either way you enter this answer, this way or this way, they're both correct and they're both identical.